Testing for anions. Anions, or acid radicals, may be classified into three categories. Group 1. Anions producing identifiable gases with dilute acids, such as carbonate, sulfide, and sulfite. Group 2. Anions producing identifiable gases with concentrated sulfuric acid. Examples: chloride, bromide, iodide, nitrate, and acetate. And finally, Group 3. Anions which are precipitated in their solutions using suitable reagents. We will focus more on testing salt solutions based on the group in which the anions and cations belong. There are several reagents which are used in the systematic procedure and will be included in the specific testing for each anion and cation. Common acids used for qualitative testing include dilute hydrochloric acid, dilute and concentrated sulfuric acid, dilute nitric acid, and unless specified, an aqueous salt solution is used in most tests. This can be made by dissolving a pinch of the salt in 0.5 to 1 milliliter of distilled water, or make a batch and use this as a stock solution for various tests. We're going to use this format for the next group of slides, where we'll say what group we're in and what ion we're looking for. We'll show the experiment, and this can go over several slides, the observation, and our inference. And right down here, we show the equation that's going on. So Group 1, reactions of carbonate. First, we add dilute hydrochloric acid to a little bit of the aqueous salt solution. We observe brisk effervescence with the evolution of a colorless gas. The inference is that dilute hydrochloric acid decomposes carbonates to carbon dioxide. Step 2. The gas from Step 1 is passed through lime water, calcium hydroxide, in a test tube. This can be done using a cork with a glass tube fitting or a disposable pipette to transfer the gas to the lime water. Observation: lime water turns milky. Inference: insoluble calcium carbonate is formed. And here's the equation for that one. Step 3. Add barium chloride solution to a little of the aqueous salt solution from Step 1. Observation: a white precipitate, a solid formation, is formed. Inference: insoluble barium carbonate solid is formed. And here's our equation for that. 4. Add magnesium sulfate solution to a little of the aqueous salt solution from Step 1. Observation: a white precipitate, solid formation, is formed. Inference: insoluble magnesium carbonate is precipitated. And here's what's going on here. Switching over to reactions of sulfide, we start with adding dilute hydrochloric acid solution to a little of the aqueous salt solution. Observation: a colorless gas with a smell of rotten eggs is evolved. Inference: sulfides give hydrogen sulfide gas when reacting with hydrochloric acid. 2. Place a strip of filter paper dipped in lead acetate solution into the mouth of the test tube. If the filter paper turns black, the inference is black lead sulfide is formed on the paper. 3. Add a few drops of sodium nitroprusside, and here's the equation for that, to a little amount of the salt solution. Observation: a violet coloration. Inference: sulfide ion forms a violet color complex ion with nitroprusside, and of course, again, here's the equation. Moving on to sulfate reactions. Step 1. Add barium chloride solution to a little of the aqueous salt solution. Observation: a thick white precipitate is formed. Inference: barium sulfite is insoluble and precipitated. Step 2. Filter the precipitate from Step 1. Add dilute hydrochloric acid solution. Observation: the solid dissolves with the evolution of a pungent smelling gas. The precipitate dissolves with the evolution of sulfite. Caution: always waft when determining the odor of a gas. 3. Add a few drops of acidified potassium permanganate solution to a little of the precipitate from Step 1. Observation: the pink color of the solution is discharged. Inference: sulfite is oxidized by potassium permanganate. The experiment. Step 4. Add a few drops of potassium dichromate solution and a few drops of dilute sulfuric acid to a little of the precipitate from step 1. Observation: a green color solution is obtained. Inference: sulfite is oxidized by potassium dichromate. Moving over to chlorides. Experiment: a little of the salt is heated with 6 drops of concentrated sulfuric acid in a dry test tube. Observation: a colorless gas with a pungent, irritating smell. Inference: hydrogen chloride gas is formed. And again, caution, always waft when determining the odor of a gas. 2. A glass rod dipped in ammonium hydroxide is introduced into the gas in the above test tube. Dense white fumes are formed. Inference: ammonium chloride is formed. Again, always waft when determining the odor of a gas. 3. A little of the salt is heated when concentrated sulfuric acid is added and a pinch of manganese dioxide. A greenish-yellow gas is formed. Inference: chlorine gas is formed from oxidation. Caution: chlorine gas is highly toxic. Perform this step in a fume hood. Step 4. A little of the salt solution is acidified with dilute nitric acid. Then silver nitrate solution is added. If it's observed that a white precipitate is formed, that means silver chloride is precipitated. Group 2. Reactions of bromide. Heat a little of the salt with concentrated sulfuric acid in a dry test tube. Observation: reddish-brown vapors are formed. Inference: hydrogen bromide gas is formed. 2. A little of the salt is heated with concentrated sulfuric acid and a pinch of manganese dioxide in a test tube. Observation: reddish-brown vapors condensing to red liquid. Inference: bromine gas is formed. 3. Acidify a little of the salt solution with dilute nitric acid. Add silver nitrate solution. A pale yellow precipitate is formed. That means silver bromide is formed. 4. Decant the clear solution from the test tube from step 3, then add ammonium hydroxide to the test tube with the pale yellow solid. Observation: the precipitate is partially soluble. Silver bromide is partially soluble in ammonium hydroxide. 5. Add about 2 milliliters chloroform and chlorine water to a little of the salt solution and mix well. Observation: a chloroform layer turns yellowish brown. Inference: bromine gas is formed. That changes the chloroform layer color. Moving over to iodide. 1. Heat a little of the salt with concentrated sulfuric acid in a dry test tube. Observation: violet vapors are formed. Inference: hydrogen iodide gas is formed. 2. Heat a little of the salt with concentrated sulfuric acid and a pinch of manganese dioxide in a test tube. Observation: deep violet vapors condensing to black crystals. Inference: iodine gas is formed. Acidify a little of the salt solution with dilute nitric acid. Add silver nitrate solution. Observation: yellow precipitate is formed. Silver iodide is formed is the inference. 4. Decant the clear solution from the test tube in step 3 and add ammonium hydroxide to the test tube with the yellow solid. Observation: the precipitate is insoluble. Silver iodide is insoluble in ammonium hydroxide. 5. Add about 2 milliliters of chloroform and chlorine water to a little of the salt solution and mix well. Observation: chloroform layer turns violet. Inference: iodine formed changes the chloroform layer color. Now we have reactions of acetate. 1. Mix a little of the salt with dilute sulfuric acid in a watch glass cover glass. Use a spatula to rub against the glass. Observation: smell of vinegar. That means that acetic acid, also known as vinegar, is formed. Caution: always waft when determining the odor of a gas. 2. Heat a little of the salt with a small amount of ethanol and a few drops of concentrated sulfuric acid in a dry test tube. Pour the mixture into excess water in a 20 milliliter test tube. The observation: if it's a pleasant fruity smell, then the inference is ethyl acetate ester is formed. Caution, always waft when determining the odor of a gas. 3. Add 2 drops of ferric chloride solution to a little of the salt solution. Observation, a deep red color is obtained. Inference, this is due to the formation of ferric acetate. Reactions with nitrate. Step 1. Mix a little of the salt with 5 to 6 drops of concentrated sulfuric acid in a dry test tube and heat strongly. Add copper turnings or paper ball to the boiling mixture. Observation, reddish-brown vapors. Brown-colored nitrogen dioxide is formed by reduction. Caution, nitrogen dioxide is highly toxic. Perform this step in a fume hood. 2. Brown ring test. Add an equal volume of freshly prepared ferrous sulfate to a little of the salt solution. Carefully add concentrated sulfuric acid to this by carefully dripping along the side of the test tube. Observation, a brown ring is formed at the liquid junction. Inference, brown ring indicates the formation of nitroferrous sulfate. 3. Heat a little of the salt with sodium hydroxide and aluminum powder or zinc dust. Observation, smell of ammonia. Inference, ammonia is formed from the nitrate salt by reduction. Caution, always waft when determining the odor of a gas. 4. Diphenylamine test. Add a few drops of the diphenylamine to a small quantity of the salt solution. Observation, a deep blue coloration. Inference, a blue-colored complex is formed when nitrate reacts with diphenylamine. On to Group 3, reactions of sulfate. Experiment 1. Add barium chloride solution to a little of the salt solution. Observation, a thick white precipitate is formed. Inference, barium sulfate is insoluble and precipitated. 2. Add excess dilute hydrochloric acid to the precipitate from step 1. Observation, solid is insoluble. Inference, barium sulfate is insoluble in dilute hydrochloric acid. 3. Add 4 to 5 drops of lead acetate solution to a little of the salt solution. Observation, a white precipitate is formed. Inference, insoluble lead sulfate is precipitated.